Students, this is lesson U3A01a. By the end of the lesson, you should be able to say, I can apply theorems of isosceles and equilateral triangles to solve problems. Alright, in the previous lesson, in U3A00, we talked about classification of triangles. So we can classify triangles based on the angle measures as well as based on the side lengths. So just to recap how we classify triangles based on side lengths, if all sides of a triangle are congruent, then that triangle is classified as an equilateral triangle. If a triangle has two sides congruent, then that triangle is classified as an isosceles triangle. If all three sides are unequal, then that triangle is classified as a scalene triangle, which brings us to the very first fact that you will need to know for this lesson, which is the definition of an isosceles triangle. The definition of an isosceles triangle is a triangle with two equal sides. So with this comes different properties, okay? Yes, an isosceles triangle has two congruent legs, but it also has two congruent base angles. And this can be proven, okay, that the base angles are going to be the same. What exactly is the isosceles triangle theorem, however? Okay, this is going to come in particularly handy when we go and prove different side and angle relationships in various geometric figures, okay, that we encounter. However, it's not going to be widely used in this lesson, but it is a good place to introduce it. So in the isosceles triangle theorem and its converse goes like this. Opposite sides of congruent angles are congruent. So we're talking about for triangles, that is. So opposite sides of a triangle, all right, are congruent, then the angles are going to be congruent. This is what it's saying. So if you have two sides of a triangle are congruent, then their base angles are going to be congruent. That's what this is saying. Opposite sides of congruent angles are congruent. Opposite angles of congruent sides are congruent. What this is saying is it's the reverse of this. If you have two congruent base angles, then the two sides that it's opposite of will also be congruent. This is the definition of an equilateral triangle, a triangle with all sides congruent. As a result of this, not only are all sides congruent, but also all angles are congruent, and all angles measure 60 degrees. What exactly is the equilateral triangle theorem then? Well, if all sides in a triangle are congruent, then all angles of the triangle are congruent. And then the reverse is also true. So again, if all sides of the triangle are congruent, then all three angles are going to be congruent. The reverse of this is true. The converse, in other words. If all angles are congruent in a triangle, then all the sides of the triangle are congruent. So this is in reverse, the logic. If we have all three angles are the same, then all three sides will be the same. Alright, so now let's try to utilize those facts to solve these problems. So right now what we have is we have an isosceles triangle, as this is indicated. So what do we know about these two sides that are the same? We have side length AB is the same as side length BC. Well, with that understanding, we now know that this angle over here must be the same as the left-hand side, which must also be 28. We know this as a fact because opposite of congruent sides, angles of opposite sides. Sorry, I get the wording and the terminologies a little mixed up. Opposite sides of congruent angles are congruent. There you go. Sometimes it's hard to say. Alright, so again, these opposite angles of opposite congruent sides are going to be the same. So therefore, if all three of the angles, okay, adds up to 180, we can easily solve for x. So I know that 28 plus 28 plus 5x plus 9, therefore is equal to 180. So I have 56 plus 5x plus 9 is equal to 180. This is going to be 5x plus 65 is equal to 180. Subtract both sides by 65. I end up with 5x is equal to 115. Divide by 5. I will end up with 23 as x. Again, opposite angles of congruent sides are congruent. All right, pause the video to see if you can solve the next one. So welcome back. Again, we have really a very similar setup. We know that AB must be congruent to BC. Therefore, we know that the base angles here must be the same. So therefore, we can say negative 4x plus 9 will equal to 8x minus 3. We need to solve for angles A, B, and C in this case. So first we're going to solve for x, and then we'll be able to find out what angles A, B, and C are. So we're going to add both sides by 4x, I end up with 12x. I'm going to add both sides by 3, we end up with 12. So therefore x will equal to 1. If x is equal to 1, then I immediately recognize that angle A will equal to negative 4 times 1 plus 9, which is equal to 5. And then angle B, therefore, well, I don't know what angle B is yet, but I know that angle C is going to be the same as angle A, which is also equal to 5. And then lastly, angle B, therefore, if both A and C are 5 apiece, that means angle B must be 170, because all three of them must add up to 180. Pause the video, see if you can solve the next one here. Again, we're dealing with an isosceles triangle, as the base angles there are showing you that the triangle have congruent base angles. All right, so welcome back. Now, because the base angles are the same, we can then set certain sides equal to one another. Immediately, I can tell that PR will be equal to QR. So with that understanding, I know that x plus 20 will equal to 8x over 3. Now, I know what you're thinking. You're looking at the 8x over 3 and it looks rather scary, but it really isn't. You're going to multiply both sides by 3. We end up with 3x plus 60 is equal to 8x. Subtract both sides by 3x, we end up with 60 is equal to 5x. Divide both sides by 5, we end up with x is equal to 12. If x is equal to 12, then I know that PR will equal to 32. We know that QR is equal to, again, 32, because they are the same length. And then finally, PQ. What is PQ? 6 times 12 minus 12, that's the same thing as 5 times 12, which is 60. And that's it.